Yo guys, so what is up? Today I have some little time to work in the project. My idea today is to start at least the design for the plates of the Shark PCB. The idea is that you could order a plate with the Shark PCB. The plates would be done in FR4, which is glass fiber, I guess, right? The same material that the PCB, which is nice, which works very well for plate material. So, but first, I was taking this look at the Shark PCB, and I didn't like the way that the LEDs were marked. Let me show you guys. So you see that the LEDs, they have this little chamfer here, right? So you know so you know the sides, which side the LED is. And in the third pin, you have this chamfer here, this 45-degree chamfer. In the PCB, as the footprint is now, the sign of the chamfer is actually this little circle, which is not quite visible. Yo Shark, what's up? So I added a chat overlay to the stream so that I could talk better with you guys. I added it with some little font, with really tiny font, but if you guys can't read it well, please let me know. If you want me to change the place that it is, I can change it to. Estou working, então maybe não preste atenção. Tudo certo, cara. Tudo certo. Depois a stream vai estar no YouTube também, se você quiser dar uma olhadinha. The PCB, it's a little different from what I've shown you guys in the previous stream. At first, you can see that it is. You see these holes here; they are lacking. They are lacking the plated holes here. You have just mechanical holes here. Now, this is because of how the PCB is mounted on the planck case. I will show you guys in Blender as soon, maybe next stream. I also added the open source hardware logo, which is quite nice. I think I'll just tilt it a little bit to the left side here. So Shark is saying, tira essas marcações de onde ficam os switches. He's telling me to take these square marks for the switches. He said it would maybe make it cleaner. Yeah, this is the back part of the PCB, right? The front part would be this one. So what do you think? Personally, I like those markings, how they are. Maybe I can take them off, but as they are now, I think I will just let them be as they are. In my opinion, it doesn't get cleaner because I took them out once, and it wasn't way that cleaner as it would look. Olha essa frente. Yep, I added the Shark logo and a Brazilian flag. Let me update the. This is the front part. This here is the front part, which is the part which will be on the top. You will mount the switches here on top. Pedro, e aí Pedro, beleza? You will mount the switches here on top. This is the back part, which will be facing downwards. But this will be the side you will solder on. Let me just update the ground, the copper planes. Okay, refilling zone. I think I okay, so let's see. So there you are. So the Shark logo and the little Brazilian flag. In honor to Steve, which is the guy that's helping me with the project and is helping me prototype, I will also add a USA flag somewhere here, also plated. Probably it will be added here. So yeah, that's just it. What am I going to do next? I'm going to take all these markings off. I will show you guys just in a moment. I will add a 3D model for the push button, which should be here. I will do this now, and I will start the plate design. Send this logo for me, please. The logo is available on the repo. Put the USA flag in the left side. Yeah, I have to make space for the USA flag, and the space will need not have traces, copper traces. It cannot be plated, gold shiny if it has traces, because otherwise it will interfere with the traces. So I can't add the flag like here or here because it has these traces. At the same time, you see this place here. It is perfect for putting the logo, the USA flag here. See, let me take these markings here off. Okay, so let me close this so it won't need to render. Yep. So I am omitting these markings here because they are already added to the component under the component. Let me show you just once I am done with this. Okay, these markings here that show the component mount place, they can make the PCB quite more polluted, in my opinion, in the end result. So what I'm doing is I am omitting them and putting them like inside the component mounting place. What do I mean by that? So let's just wait it for render. Okay, so if you go here, for example, you see that the fuse here, it has no fuse yet, but you have the F1 inside, like under the fuse. Once you solder the fuse on, this F1 will disappear, and you will know. Because these markings, they are not needed after you solder the components. I mean, you will hardly make maintenance on this kind of board, so it's not really needed to keep those markings here. So I am adding them under the components. So if you take here preferences, show 3D models, it's rendering here. See, they are under the components, and once you solder the components on, it gets, it just gets under the component, and you won't see them after the components are soldered, which in my opinion makes it cleaner. I have to add these the markings for these capacitors. They are the voltage regulator capacitors for the microprocessor. There are some here that I need to put off. So this guy here. What else? The age markings. So the plated hole markings, you not needed. Also not needed. is it here? Here. Yep, so there we have it. So now the components, the component markings are put under the components, and it will make the board look cleaner after we solder those on. Also these hole here, the H12 guy. Yep, so there it is. It is ready for prototyping. The first prototypes are on their way. The next step here is to make the plate design and to make the THT version design. The THT version will use a Prodigy, and all the components involved will be THT versions. Both, I mean, all diodes, all resistors, you can solder them on. It will be easier to do for a, you know, not like these SMD components. They will probably need stenciling to do. And that's not something you want to do for a small amount of boards, say 5 of them. So if you want the Shark and you want the experience, the 40% experience, but you don't want to solder SMD components, and THT version will be available so that you can do it easier at home. Let me save this. So done. So what am I going to do now? The plate should be designed to work with both low pro and the high pro versions of the planck case. So what am I going to do? I have here the planck PCB module. The planck PCB module is available on I think the GitHub content. Let me see. It's available on OLKB parts here. So you see. So here we are, PCB module. When you add this module to KiCad, let me show you guys. So let me save this first. So the Shark, it's saved. I will decide on this later. Let's just save this. Okay. So what am I going to do? I'm going to add the plate files. So let's see. Okay. So oops. So adding a plate directory. Here we are, plate, and I'll copy all the PCB files from the Shark. So shark.pro and Shark, I think it is KiCad PCB to plate. So there they are, and then I'm going to plate. So let's go Shark Pro plate, Shark plate Pro, and then Shark plate KiCad PCB. Oops. PCB. Yo, Kawabata. How are you, man? Nice having you. So we are doing the plate files for the Shark. So here we are, plate. I will open, let me close this guy. So cd sharkplate dot sharkplate sharkplate.pro. What's your SO? I use Arch Linux. I'm using Arch right now. Okay, so this is the SharkPCB, right? Let me add, just to show you guys, the planck module. So let me add here the planck module. I'll have to make a folder for you too. So it was, I downloaded it. Where the heck did I download it? PCB module KiCad mod. So I'm downloading it on the GitHub page. Save as. Let's just add it like temp. Nice. Okay, so when we go to KiCad, let's just add preferences, footprint. Okay, okay. Planck PCB module. So this is the Planck PCB module, which is supposed to add compatibility for the Planck. Let's see. Yep. So you see, it has the dimensions of the Planck case and all and such. I think these marking here is the PCB size, right? It fits just inside the Planck case. I have tested it on Blender, so it should work nicely. The plate should cover the whole case. If you take a look at some Planck images, the plate gets all over the case, at least a low pro case. So for example, see, so the plate covers all the case. So that's what we are going to do today. We are making the plate all over this case here. Eu quero testar um SEO, mas não sei qual ainda. Linux. Começa por Ubuntu. Se você vai começar, so Shark wants to start with Linux. Start with Ubuntu Linux, which is probably the best one to start if you don't have any experience with Linux. Arch Linux is an advanced distribution in the sense that you have to have some good understanding of how Linux works, because everything is it's really from scratch. You install the system on a command prompt, you configure the system, everything on command prompts, and the graphical part is just, the graphical part. So you have to have this nice understanding of it, and you must be willing to learn. I mean, Arch Linux is really nice because everything is really well documented in the Arch wiki. So anyway, when you have a problem, you take a look at the Arch wiki, even the forums, and I'm sure you will find it. Okay, so I'm going to start doing the plate now. So see that we have kind of a mess here, but everything that I want really is the edge cuts. So I want to take the edge cuts of the plank, which should be something like this. So let's see here. So let's put these two edge cuts. Okay. And then again, now doing the round corners. Let's see. Nope. You. Edge cuts. Nice. Here now this guy. Um tempo estava usando Elementary que é Ubuntu based, nunca usei. Elementary nunca usei, na verdade acho que eu nunca usei nenhum Ubuntu based. Só o próprio, né? Não sei dizer. Mas assim, pega uma distro que é conhecida, cara, não tem muito erro não. So we are closing it. Yep. Closed. And so now what I think should be done is the cuts for the switch, like the switch slots, right? To know the size of the switch slots, I think that the MX switch datasheet has that size. So if we go here to, I think it is in the MX repo. So let me see what's in here. MX socket, no, MX switch. Does it have any here? So you see that it has the markings for the switches, for the switch slots, and these are the markings that it recommends. So 0.551, I reckon it must be in inches, right? Yep, 0.551 inches. How many millimeters are those? 2 millimeters, 14 millimeters. Nice. So let me see my grid settings. You know what? You know what would be better if I did. I don't think this is going to work as I think it is going to work. I mean, I think I will have to make a custom based footprint. I think that would be better. Yes, indeed. I think I will. So let's do it. So let's leave this at the side for a moment and open KiCad again. Here. Okay, now I will do new footprint. Let's say switch slot 100. Yep. Okay, so grid settings. 0.1 millimeter would be better. Okay, so according to the datasheet, the slot should be 14 by 14 millimeters. Let's do it squared for now, and then we'll add some curvature to the corners. So let's see. So I want it on the 7.7. Let's see. Yep, that's better. So 7.7 and then we go 7 to 7. So this should be a switch slot. What am I going to do now? I'm going to add, I saw Felipe doing a unboxing and a building of, I think it was a key cult that had, key cult number 1, that had a plate made of FR4. And the plate was gorgeous. I mean, it was, I think, as I have seen on his string, it was matte black, and the slots were gold, were plated. They were shiny gold. So it is really, I found it to be really, really, really pretty. So I wanted to do something like that. I don't think I can move this to the edge cuts, can I? No, I cannot, but I can edit it. Nice. So, so if I do say this, let's see if I can do something like this. Layer. Let's put in the copper layer. Yeah, okay. Let's give it some nice thickness. Maybe 1.5 2 is nice. Maybe not 2, maybe 1.5. Okay, so here, so the slot should be something, let's see, when I take a look at the 3D. Okay, so let's add this pad here, SMD pad, paste, nice, let's put this here, and then created, and then when we, nice. So see, the white line is where the slot hole should be, and then it has this nice shining gold outline to it. I don't know. The problem with KiCad is this white line. I haven't found a nice way to put this white line in the edge cut layer. So the idea is to edit those manually. How do you do that? So let's just save it as slot 100, and then create new library. Let's add it in the MX folder. MX slot. Switch slots. Nice. So footprint library, browse libraries. Let's go to MX switch slots 3D. Okay. Let's save it in the switch slots. Saved it is. Okay, nice. So now what I want to do is take these green lines, which are the white lines in the 3D model, and put these lines in the edge cuts, layer, so that they are actual cuts in the PCB. And the only way I have found to do this is by manually changing it. So you go to Max, switch slots, and then that's the slot 100. So we added it wait, oh, the graphic one. Okay, so you see these guys here with the F silk. Let's put those in the edge cuts one. So F silk. Yes, so edge cuts. Nice. Save it. And then when we get here, let's add that guy. It's added. Let's see if it worked. So slot 100, and if we add it like here, let's say for example, so I think it worked. So we have to delete all these guys here. So okay, so it is centered. The center is where I want it to be. So I'll just delete the SharkPCB as how it is right now. So all these dudes here, let's just delete them for the sake. There we go. Okay, so we have the planes also. So we have the center where it should be. Maybe this is not the best way to do it, but let's just, you know, for the sake of the argument. So grid settings, the spacing is 19 millimeters. I want half the spacing, so 9.5. Oops. 0.5. 9.5. Okay, so let's add the switch slot. One here. One here. One here. Let's add 4 of them just to know how we stand. So there we are. So you see that the plate is starting to take some form. Maybe it wasn't so nice. I should have marked the places where the holes should go for the mounting and such, but this is the basic idea of the thing. I mean, I should have done it more carefully, but I think that's a great starting point for the project. So let's just undo this. So okay, so what do I want in the plate here? I want the hole markings. So say these holes here, for example, I want them here. I also want the plated holes. Yeah, I also want those. I also want, I think maybe it would be nice, where is the reset push button? Somewhere around here. So let's just do this. So this guy here, put him here. Oh, it's the grid that's making this. Let's edit this grid. Let's see. I also use the calculator for this kind of thing. So 19, say divided by 16. It's nice. So you here. What else would I want? Maybe these holes, they are way too big, right? I want some smaller ones. So yeah, so let's just remove this guy, and maybe if we did something better, like that wouldn't be too intrusive on the plate. Let's divide this by 2 again. So what I'm doing is add the screw holes in the plate, so that you can, as soon as when you mount the plate and the PCB to the case, you will have screw holes in which you can screw the PCB plus plate in the case. You want these holes to be fairly big. I mean, you don't want the screwdriver to keep hitting all the borders of the screw hole. But at the same time, they shouldn't be too big, so as to interfere with the switch slot. So I think this is a nice size. Let's add them all. And there is also a push button. Where is it? Yeah, it is fairly important to have a push button. There are many PCBs recently that are coming out without a push button, but they the problem is that if the firmware is not really good, or somehow something happens to the keyboard that you want to reset it, or the firmware just crashes, you want a hard reset. You want something that you can press to hard reset the microcontroller, and that's why I'm adding a push button to it. I just can't remember where is the push button in this whole of a mess here. It is somewhere around here though, as far as I can remember. Here it is. So so there we go. So let's delete you. Let's delete these guys here. You, and exclude the holes we have just made. Not you. Also not you. Not you. Not you. Not you. The circle and the push button circle. Here. Let's see if this worked. Nice, it worked quite nice. Let's delete this guy. There should be one here, right? Yeah. Let's just delete this pad. Better, way better. Let's just leave the circles we want in. You, this guy, leave him there. You, here and here. Okay, there they are. You have these, everyone's here. Everyone is also here. So again, let's do it. So all of these guys, and take off the holes we have drawn. incline, U, and the push button hole, so that you can press the button once if the keyboard firmware crashes. And I think that's it. Delete it. And there we go, all the holes there. Let's delete the ground planes. Not you, also not you. Oh, and there's one for the center hole too. Nice, so let's see. Yeah, so there they are. The holes for the mounts. Now let's add the slots. Okay, but first let's set the settings. 9.5. So here, way easier. A PCB é compatível com a case Low Pro do Planck? Não sei, já falou. Sim, a case ela é projetada para ser compatível com a Low Pro. Inclusive, eu tenho uns renders bem legais com a Low Pro. E vai ser massa. Eu estou fazendo a plate agora. Uma plate igual a do próprio. Ó. Eu só não sei se ficou bom esses outlines aqui. Mas essa aqui é a ideia da plate, tá vendo? Agora, como é que ela ficaria no case? Deixa eu mudar para inglês aqui. So guys, this is the final idea of the plate, right? What would be the difference? In the bottom row here, there should be some space for the to use. So actually, here in these four guys here, they should be all one, and maybe add some extra space for the stabs. But this is the final idea. So RPHLF, I don't know if that's a nickname or something, asked, is the PCB compatible with the Low Pro case of the Planck? I don't know if I have already talked about it, and I lost the answer. So yes, it should be. It is designed to be compatible with the Planck Low Pro and High Pro cases. And what am I going to do now? I'm going to show you guys that it is in fact compatible with those cases. And so I'm going to save this, and I'm going to export the 3D model of it. So let's see, export VMRL. Okay, SharkPCB plate, Shark plate, save, and export. Nice, there we go. So now I'm going to export the 3D model for the SharkPCB. Shark Pro. Export. Enfim, o RPHLF. Eu vou mostrar para você que ele é de fato compatível com o case do Planck. Eu vou mostrar no modelo 3D aqui, bem massa no Blender. Vou mostrar aqui rapidão. Eu estou exportando os modelos 3D agora. Eu acho que ele exportou. Exportou. Foi. A 3D model of the Planck Low Pro and High Pro cases is available on the OLKB parts repo. I don't know if are licensed under the Creative Commons. I just don't know if it is okay for me to show this on stream. I mean, it is publicly available. I'll ask Jack once I reach to him. But anyways, what am I going to do? I'm going to here. So the low pro button. So this is the low pro bottom, right? It is quite nice that you can buy one of those in the Mastrop. Mastrop sometimes you can buy a V stock. I think it is $20, $20. It's really, really inexpensive. So download, save. Okay, so let me open Blender. So here I have it. So first of all, import. So first of all, I want to import the cases in STL, right? So import STL, downloads, here we are, the load pro button. So here is the load pro button of the planck. I'm going to import the PCB. Import WRL desktop Shark. It's going to take some time, it's really heavy. Also, my computer gets real slow when I'm streaming. I think that OBS takes quite some resources of my CPU, so it takes some time. Let me just wait this. Okay, so the PCB is here. Let me do some adjustments. So let's see. Yep. So let's move these guys. Let's join them. Also taking quite some CPU resources. There we go. So let me move this. Why is it not moving everything? Let me see if I can just import the PCB again. I haven't quite got myself acquainted to Blender. And it takes quite a toll on my computer. So let me import the case again. Okay, so it's imported. Import the PCB is going to take some time. Still waiting for Blender to work. Okay, so properties. so let's rotate it. So let's rotate the case. Here, this guy should be here, so 180. Here, and then here. Let's adjust it just right on the PCB and push it a little bit back. See, so it is fully compatible with the low pro case. It will also be compatible with the high pro case, right? Now I am going to add the plate file, right? So import another WRL, and it's going to take some time also. Where is it? Let's just delete this one for now. Okay, so it should fit the case quite nicely. Just some steps up. And there you go. See, fully compatible with the case. Maybe some measurements are out of place. I mean, let's see. I'm missing some PCB here, see? So it's in the X coordinate, I guess. Yes, it is. So see, RPLF, RPHLF. So there you go, fully compatible. It should work just as well. You see that here you have the mounting screws, and here should be the mounting screws for the PCB. These should be the mounting screw for the plate, and this guy here should be right on the push button. I'm going to add a 3D model for the push button so that we can do nice renders. So yeah, fully compatible. I am working with a turnaround for a little bit of a problem that came with the Hypro case. The Hypro case uses 2.5mm standoffs to support the PCB, and I haven't found a nice cheap way to replace those. I am working on a turnaround with Steve. We are maybe thinking on use some self-locking nuts or maybe some nylon nuts, but that will have to wait. Also, since I don't have a Hypro case, I only have a low pro case that I bought on a B stock sale on Massrock. I won't have any way to test that. So yeah, that's it. So guys, this we are walking towards the end of the project. This should be the final product. I wouldn't say product. I would say the final form of this version. We are prototyping it. Really, everything that should be done now is, quite frankly, some nice renders and prototyping it. The prototypes are on their way. I am setting with Steve a nice way to do it. The parts list is available, so this should be the final version, the final version of this revision. Do you guys have any questions? It seems like you don't. So I'm going to end the stream here. I'm going to finish this plate design and maybe take a shower and go to sleep. If you guys don't have anything to ask, have a good one, and any questions, any doubts, just hit me up on Discord. See you guys.